Hi, my name is Hafizul Helmi bin Hairuddin, and today I would like to present about photodiode, LED and laser diode. Table of content: photodiode, LED and laser diode. Photodiode. A photodiode is a semiconductor p-n junction device that converts light into an electrical current. When a photon of sufficient energy strikes the diode, it excites an electron, thereby creating a free electron. This mechanism is also known as the inner photoelectric effect. This device can be used in three modes: photovoltaic, as a solar cell, reverse bias as a photodetector, and forward bias as an LED. A photodiode is a type of photon detector capable of converting light energy into electrical energy. Photodiodes are similar to regular semiconductor diodes except that they may be either exposed to detect UV or X-ray or packaged with a window or optical fiber to allow light to reach the sensitive part of the device. A photodiode is designed to operate in reverse bias. Working principle: a photodiode is subjected to photons in the form of light which affect the generation of electron-hole pair. If the energy of the falling photon is greater than the energy gap of the semiconductor material, electron-hole pairs are created near the depletion region of the diode. The electron-hole pairs are separated from each other before recombining due to the electric field of the junction. The direction of the electric field in the diode forces the electron to move toward the N side, and consequently the hole moves toward the P side. As a result of the increase in the numbers of electrons on the N side and hole on the P side, a rise in the electromotive force are observed. Now when an external load is connected to the system, a current flow is observed through it. The more the electromotive force created, the greater is the current flow. The magnitude of the electromotive force created depends directly upon the intensity in the incident light. This effect of the proportional change in photocurrent in which the change in light intensity can be easily observed by applying a reverse bias. Since photodiodes generate current flow directly depending upon the light intensity received, they can be used as a photodetector to detect optical signal. Built-in lenses and optical filter may be used to enhance the power and productivity of a photodiode. Application of photodiode. Photodiodes are used in consumer electronic devices such as CD players, smoke detectors, and the receivers for infrared remote control device used to control equipment from television to air conditioner. Photodiodes are used as a light sensor. Photodiodes are often used for accurate measurement of light intensity in science and industry, and they are also widely used in various medical applications such as detector for computer tomography, instrument to analyze samples, and pulse oximeter. Next is LED. LED is an acronym for light emitting diode. A light emitting diode is two LED semiconductor light source. It is a p-n junction diode which emits light when activated by a suitable voltage is applied to the lead. Working principle: when the negative end of a circuit is hooked up to the N-type layer and the positive end is hooked up with a P-type layer, then electron and holes start moving. If we try to run current the other way, with the P side connected to the negative end of the circuit and the N-type side connected to the N, current will not flow. No current flow across the junction because the hole and the electrons are each moving in the wrong direction. Application of LED. LED use fall into three categories: indicator and signals, lighting, data communication, and other signaling. Laser diode. Laser stand for light amplification by stimulated emission of radiation. A laser diode is an electronic device which converts electrical energy into light energy to produce high-intensity coherent light. Laser diode is very small in size and appearance. It is similar to a transistor and has operation like LED, but it emits coherent light. The materials which is often used in laser diode is the gallium arsenide. It is also called injection laser diode. It works on forward biasing. Construction of laser diode. The laser diode is made up of two layers of semiconductors, P-type and N-type. The layers of semiconductor are made up of gas doped with material like selenium, aluminum, or silicon. The construction is same as that of LED except the channel used in laser are narrow to produce a single beam of light. Another one more different in a laser diode is that an intrinsic layer of gas, undoped, is also present. This layer is called active layer. The active layer is enclosed by a layer of lower refractive index. These act as optical reflectors. This layer along with active layer form a waveguide so that light can travel only in a single path in a single and fixed direction. The beam of light is produced in this section. The metal contacts are provided to facilitate biasing. Working principle of a laser diode. The laser diode works on the principle that every atom in its excited state can emit photon if electrons at higher energy level are provided with an external source of energy. There are basically three phenomena by which an atom can emit light energy, and that are absorption, spontaneous emission, and stimulated emission. Absorption. In absorption, the electron at lower energy level jump to higher energy level from valence band to conduction band when the electrons are provided with an external source of energy. Now, they are held at lower energy level valence band and electron at higher energy level conduction band. Continuous emission. Now, if the electrons in higher energy level are unstable, then they will tend to move to the lower energy level in order to achieve stability. But if they will move from higher energy level to lower energy level, they will definitely release the energy, which will be the energy difference between these two levels. The energy released will be in the form of light, and thus photon will be emitted. This process is called spontaneous emission. Stimulated emission. In stimulated emission, the photons strike electron at higher energy level, and these photons are supplied from an external light energy source. When these photons strike the electron gain energy and they recombine with holes and release an extra photon. Thus, one incident in photon stimulates another photon to release. Thus, this process is called stimulated emission. Application of laser diode. Fiber optical communication system, barcode readers, laser printing and laser scanning, in medical, in surgical instrument, in CD players and DVD recorder, range finder. There are a lot of advantage and disadvantage in laser diode. Advantage: low power consumption device, economical as its cost of manufacturing and operation is low. It can be operated for a long time, portable due to its small size and internal architecture, highly reliable and highly efficient. Next is disadvantage. These are temperature dependent, and thus its operation is affected by the change in operating temperature. It is not suitable for high power application. This is my reference, and that's all from me. Thank you.